Hello. In this video, we want to find all relative extrema for the following function. We have f of x equals x to the 2/3 minus x to the 5/3. Again, we want to find any critical values. To do so, we find the first derivative. So f prime of x here, bring the 2/3 down in front. That makes that 2/3 x to the 2/3 minus 1 is negative 1/3. And then minus, bring the 5/3 down in front. X to the 5/3 minus 1 is 2/3. Good. Now, because there is a negative as an exponent, this is going to give me 2/3 in the numerator over x to the positive 1/3. And then minus 5/3 x to the 2/3. And technically, that's all over 1. If I want a common denominator, I'm going to multiply the second one by x to the 1/3 in both the numerator and denominator. So this is going to give me 2/3 and then minus 5/3 x to the 2/3 plus 1/3 is 3/3, and 3/3 is just 1. And then all over x to the 1/3 power. Good. And honestly, if you want to get rid of that over 3 there for both of those, you can multiply the numerator and denominator by 3. So f prime of x here can be thought of as 2 minus 5x all over 3x to the 3rd power. Excellent. Now, that is the derivative. What we want to do now is find the critical numbers. The critical numbers occur when the numerator is equal to 0. In other words, the derivative itself is equal to 0, or the denominator is equal to 0. So the numerator here is 2 minus 5x. The denominator is 3x to the 1/3 power. Solve, subtract 2, makes that negative 5x equals negative 2, and then divide by 5, so x equals 2/5. For the other one, divide by 3, so x to the 1/3 equals 0, which means x equals 0. So we have two critical numbers here, 0 and 2/5. So on the number line, we have 0 and we have 2/5. The next thing we want to do is choose critical numbers, or not critical numbers, test numbers. A number to the left of 0 would be negative 1. Between 0 and 2/5, well, let's just say 1/5. I know for sure that would be. And then to the right of 2/5, let's just say 1. And we're going to plug those into f prime of x. Now, I want to know what is f prime of x. Well, f prime of negative 1, I need to know what that is. So if I type that into the calculator, that's going to give me negative 2.333. Which tells me that this is negative, so it's going down from left to right. Between 0 and 2/5, I plug in the negative 1/5. Sorry, the positive 1/5. So f prime of 1/5, well, what is that? 0.57, which is a positive value. So it's going up from left to right in that region. Now, to the right of 2/5 is 1, and that's going to give me f prime of 1 is negative 1. But that is negative, so it means this is going down from left to right. Excellent. So the critical numbers of 0 and 2/5, this is giving me a negative and a positive, and then in the positive and then negative. So it's switching signs and it's switching signs. Now both 0 and 2/5 are in fact part of the domain, because 0 is not in the denominator for either one of these two, and 2/5 work out as well. And the way that you can tell that is if you just take this and plug in, what is f of 0? When you plug in 0, you're going to get 0. That's for the y1, or the original function. For f of 2/5, which is 0.4 if you will, type that in, and that's going to give you 0.2 0.3257. Now notice that the reason that I know that both of these are in the domain is because when you plug it in, you get an actual number for either one of those two. You don't get an error. Good. Now notice that we have a relative minimum here because it's going down and then back up. And we have a relative maximum here because it's going up and then down. So the relative maximum, the actual maximum value is 0.3257, and it occurs at x equals 2/5. And there is a relative minimum of 0 at x equals 0. Good deal. Alrighty, I'm going to go ahead and go to the calculator to kind of show you what's been happening with this. Alrighty, I will see you there. Okay, so here we are at the calculator. So on y1, I typed in the original function, and on y2, I just typed in what I got when I first did the derivative without doing any of the extra algebra. So this really does kind of help. That way, in case you make a mistake getting to that fractional form. Now, if I graph this, the blue is the original, and the red is the derivative. Now, the red is just kind of getting in the way here, so. Oops. There we go. Here is the derivative. Notice that if I zoom in, it's a little bit easier to see. Notice we have a sharp edge happening there, and then it's going down that way. Now notice that there's a maximum value there. Now, going to the table, I still have it on ask. So at -1, oops, let me turn the y2 on now. So at the -1, the y2 value, which is the derivative value, is -2.333, or -2 1/3, basically. At 0.2, which is the 1/5 value, we got the 0.57, and at the 1, it gave us -1. Notice the only thing I care about for these three values are the y2s. Now, on the 0 and the 0.4, which is the 0 and the 2/5, we got an error and a 0 over here because these are in fact critical numbers. And these are the y values at these x values. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.